Next is the triangulation of both the faces. Here you can see that what we are doing is we are creating a for loop in which we are trying to triangulate the first face. Here you can see in the first point what we are doing is we are passing a landmark point with the index 0. Similarly for point 2 and point 3, and all these points are further stored into a NumPy array. After that we are creating a bounding rectangle which will bound the image, bound the face, and we are taking its coordinates x, y, width and height and store into a rectangle. Similarly, we'll crop the triangle from the image as we have already triangulated it, and next we will create the mask. Here you can see that we have created the mask using the np.zeros and pass the height and width of the mask. Next we will store all these points and the x and y values, that is the x and y coordinates, into a NumPy array in a variable named points. Next you can see here that we are creating a line space. Line space is required for the mask. So we are using the cv2.line function, passing the line space mark and passing 2 points, point 1 and point 2. Similarly, for the second line we are passing the point 2 and point 3, and for the third one we are passing the point 1 and point 3. And then we are applying a bitwise operator here. As we have done the triangulation of the first face, similarly this step, the triangulation of the second face, is exactly same. Here also we are creating 3 points, saving them into a NumPy array, creating a bounding rectangle, and all the steps are exactly same as we have done above. In the end we are warping triangles. Here you can see that we have used points, which is np.float32 points as we have already defined above, and a point 2 also for the second image. We are using a function called cv2.getAffine and it will transform both points 1 and points 2. Similarly, we are using the warp triangle, which will contain the warp affine cropped triangle, the crop triangle as we have found above. Next we will use the bitwise operator and pass both the warp triangle and the mask. Till here our images have been triangulized. Now next what we'll do is we will reconstruct the destination face. So we have extracted the face from the source image and we have deleted the face of the destination image. Now we'll replace the destination face with reconstruct the destination face using the CVT color and threshold function. Here you can see that we are using the CVT color function and threshold. Finally, we'll use the bitwise operator, and here you can see that we are finding out the image to new face rectangle area and passing the image to new face and the warp triangle. Let's run this cell and complete this step. So what we did here we performed some of the operations similar to the destination image as above. After that we have the triangulation of both the faces. We take the triangle of source face and we extract them. We also need to take the coordinates of the triangle of the destination face so that we can warp the triangle of the source face to have the same size. Next what we will do is we will face swap. So once we have cutted and wrapped the triangles, we need to link them together. We simply rebuild the face using the triangulation pattern we have found above, with only difference that this time we will put the wrapped triangle around it. So here you can see that we are using the fill convex poly function and the bitwise function for this. Let's run this cell and face swap it. So it's done. Now the face is ready to be replaced, and now we cut out the face of the destination image. to make space for the new face. So we take the new face and the destination image without face and we link them. Here you can see that I have taken the image of the with no face and the new face and we are adding it. So the result will be a new face on the destination image. Let's run this. It's completed. Finally, the faces are correctly swapped and it's time to adjust the color. So we need to adjust the color also in the source image to fit in the destination image. So on OpenCV, we have a built-in function called seamless clone. As you can see here, I have used seamless clone. What it does is it matches the destination image with the current image that we are using. So we need to take the new face created on the 6th step and take the original destination image and its marks to cut out the face. We need to get the center of the face. Let's run this and use the seamless clone function. Finally, we'll print out the final image, the seamless clone that we have created. Let's run this cell and see the image. So here you can see, here you can visualize the output NumPy image which we have converted using the pillow into an image object, and this is the final swapped image. This is the destination image swapped by the face of the source image. So with this we came to the conclusion of this project. So we started with downloading the pre-trained model for face landmark and downloaded the image from the internet that we worked on. We used CV2 and dlib for a lot of pre-processing, as you have seen here, for both the images, and we used different functionalities to make reach to the end, which is swapping the face of the source image with the destination image. So the scope for this project will be, this project can be used for learning and understanding different concepts of computer vision. It is a fun project. And this project can also be used to build augmented reality applications like Snapchat, etc. So next I'll show you how to create a application for this project. So let's move forward.